So, out of the different services provided by the data link layer to the upper layer, that is the network layer, we have studied the framing and the flow control techniques. The next kind of service that is provided by the DLL to the upper layer is the error control. Till now in the flow control protocol, what we assumed is the communication between the sender and the receiver was error free. So, we are considering only the situation when the speed of the sender and the receiver should not mismatch, or the size of the data or the capability of the receiver should not be so less that the packet that is being transmitted by the sender will be dropped. In none of the situation we considered about the error that is present in the communication of the data or the frames. But can you imagine any communication which is error free? Not possible. Definitely in any communication, in the any data transmission, there exists some kind of error, and the error can be of any type. Forget about the noise that is being added or for any reason. So, how the errors are being handled by the sender and the receiver, meaning the DLL of the sender and the DLL of the receiver. Now, let us say we have a sender here, we have the receiver here. The sender transmits a frame to the receiver. Now, when the receiver receives the frame, what it does? It processes it. And if the frame that is received, if that is correct, then only it processes, right? It cannot process a wrong data that has been received. And after processing it, what it should do to obtain the reliability of the transmission? It can send an acknowledgement, as we have seen in case of an flow control protocol. So, the frame is transmitted by the sender and acknowledgement is transmitted by the receiver. Now, let us say the frame that is transmitted is lost on the way. Let us say the frame that is being transmitted is lost on the way. It does not reach at the receiver. What will happen? When the receiver does not get the frame, what it will do? Can it send an acknowledgement to the sender? No. That means in this scenario, no acknowledgement will be transmitted. When no acknowledgement is transmitted, the sender must be informed that the acknowledgement has not been transmitted. So, there is a problem in the transmission. So, when the sender can come to know that the acknowledgement is not coming, you know the flow control protocols, the both last what we studied in the last class. The sender was waiting for a acknowledgement to come from the receiver in the stop and wait, and in the sliding window it was not waiting for every frame to be acknowledged, but at least the number of frames in the window, for that it was supposed to get the acknowledgement, then only it can expand its window size and transmit the further frames, right. That means in any case an acknowledgement is required, maybe for individual frames or maybe for multiple frames. Now, let us say the sender is not receiving the acknowledgement. So, till what time it will wait to receive the acknowledgement? There must be a fixed time till which the sender will expect the acknowledgement to come. Now, for this, whenever a frame is transmitted, the sender starts its or resets its a timer called the retransmission timer. I am sorry, called the timeout timer. That means every frame is associated with a timeout period. Every frame is associated with an acknowledgement, as we have seen. So, when the frame is transmitted, the sender restarts its timeout period. Let us say the timeout period is 5 seconds, meaning the sender is expecting an acknowledgement from the receiver within the next 5 seconds. If it does not come, the sender understands that my frame that I have transmitted has not received to the receiver or not delivered to the receiver. So, when the receiver does not find the or does not get the frame in this scenario, it does not send back the acknowledgement, and after timeout occurs by the sender, what it is supposed to do? It will retransmit the frame. That means Another mechanism is retransmission, right. This is one scenario. Another scenario is, let us say the receiver receives the frame, sender sends the frame and receiver receives the frame, but when it detects the error, it finds that the frame that is arrived is erroneous. You know the different error detecting mechanisms are there. So, by this error detecting mechanism, the receiver understands that there exists an error in the frame. Can it process the frame now? No, it should not, because if it is processing, the whole of the thing is wastage. So, what it does, it receives the frame, but because it is in the erroneous condition, it informs the sender saying that the frame that he has sent is having an error. And what is that message that says to the sender is a negative acknowledgement. So, another mechanism is a NAC. So, an ACK says that the frame is in the correct order, correct form, received. NAC says the frame is received but with errors. Now, once the NAC is received by the sender, what the sender is supposed to do? It will again do the retransmission, right. That means during data transmission, it is not only the job of the flow control, but also the error control mechanisms are to be incorporated, like the frame should be acknowledged, maybe in a positive way, maybe in a negative way. The frame needs to be acknowledged to the sender. There must be a provision of sending the acknowledgement within a time period, that is called timeout timer, and there must be a provision of retransmitting the packet if it is in the error form or if it is not received by the receiver. So, combining all these mechanisms to handle the different kind of errors in the frame or in the data, the mechanism as a whole is called automatic repeat request, ARQ mechanism. The objective of studying this is, you must know what is the error control protocol does, or what is error control meaning in data transmission. Error control means either the data will be lost or data is damaged. So, cases are, first case is the data is lost or the data is damaged. If it is lost, then there must be a timeout. If it is damaged, then there must be a NAC. If it is in the correct form, data in the correct form received, there must be an acknowledgement to acknowledge it. And there is another case we will consider. Let us say the acknowledgement is lost. What will happen in this case? Let us say your sender sends the data, receiver receives it, and it sends back the acknowledgement, and the acknowledgement is lost on the way. Possible? In that scenario, what the sender will do? Again, timeout will occur. So, now the timeout. And when the timeout occurs, the sender will again retransmit as per the ARQ mechanism. But this frame was already received by the receiver in the correct form. Let us say the frame F that was received. But because the acknowledgement was lost, the sender is again resending the frame. So, what the receiver understands now? Because I am getting a duplicate packet, the first thing it does is it discards the duplicate. So, the next very important mechanism is it must be able to discard the duplicate frames. Why? The reason is, if it processes the duplicate again, the resources are waste. So, this is another mechanism to be done. It will discard the duplicate frames and then it will send back the acknowledgement again. So, timeout occurs, the sender retransmits the frame, the duplicate packet arrives at the receiver side, the receiver retransmits the acknowledgement again. Maybe a acknowledgement, maybe a NAC, but it transmits, right. So, this is what are the different mechanisms of your error control, or what is the ARQ mechanisms you say. Now, with this, mechanisms of this retransmission, ACK, NAC and all those, the error control has got the protocols that is understood by the sender DLL and the receiver DLL. So, what are the ARQ or the error control protocols? Similar to your flow control protocols, the ARQ, the error control too has got two different kind of protocols. One is the stop and wait and another is the sliding window error control protocol. And this sliding window again there are two types of protocols that belongs to this sliding window mechanism. One is selective repeat and another is go back N. So, these are the different error control protocols that support the DLL to maintain the transmission without any error. So, what is stop and wait protocol? As we know, this is basically it is a half duplex, it supports half duplex mode of transmission or service. So, stop and wait error control protocol. Whatever we saw, that is the same as your all those mechanisms are available in the stop and wait. Let us say you have the sender, you have the receiver. The sender sends the frame F0, the receiver transmits the ACK 1. This says the transmission is correct, I mean the successful transmission. So, here is a successful transmission. Now, let us say this fellow sends the F1 which is lost on the way, and because it is lost on the way, so there is no acknowledgement from the receiver side, right. So, and once the F1 is transmitted, your timeout has started, and by the time the timeout is over, so no acknowledgement has been received. So, which frame will be now transmitted again? Same F1 will be transmitted. Now, F1 is being transmitted. This is successful. What it does? It sends the acknowledgement for 0. This is stop and wait. So, we can go for the frame 1, frame 0 that way. Now, once the acknowledgement 0 is transmitted and this is lost on the way. When this is lost on the way, your again timeout occurs. Any problem that side? Any problem? If you have any query, just wait for 20 minutes, then you can ask me the questions. No gossiping among yourself. Now, the acknowledgement 0 is lost, so timeout occurs again, and with the timeout, again your retransmission takes place for F1. What the receiver understands? I got the F1 here and again I am getting the F1, so that means it has to discard the duplicate. And what it does? It retransmits the acknowledgement 0. Now, the sender receives acknowledgement 0, so he understands my F1 has been received safe. So, what it does? It sends the frame 0. Let us say there is an error in frame 0, there is an error. What the receiver does? NAK for what? NAK for 0. That means you retransmit the F0 again because that frame has got an error. So, your acknowledgement says what is the next frame expected, meaning the previous has been reached safe. Your NAC says there is an error with the frame that I have received. So, now once NAC is received, this fellow now sends the F0 again, right. Now, let us say again there is an error. So, what it does? It sends the NAC for 0. Let us say this NAC is lost. Does it affect the transmission? So, if the NAC is lost or NAC is received, in both the situation what the sender does? It does the retransmission, right. So, if it is lost also, it sends the F0 again, and let us say there is a success here. That means the situations like loss of a NAC or arrival of a NAC indicates a retransmission, but arrival of a ACK does not go for retransmission, but loss of ACK goes for a retransmission as well as a discard of the duplicate, right. So, this is what is your stop and wait protocol with all the different cases, your lost data, your damaged data here, your lost acknowledgement and the again damaged data with lost NAC and all the provisions. Other than this, can you think of any other case that may arise during transmission? The acknowledgement could be lost, the NAC could be lost, the frame could be lost or the frame could be damaged or erroneous, right. Probably these are the 4 cases that can occur, and the stop and wait protocol for this handles all the situations with the ARQ mechanism. This is what is your stop and wait protocol for error control by the data link layer. Coming to the next kind of error control protocol, the sliding window protocol. On the sliding window, we will first see a go back N protocol, a very simple kind of protocol, go back N protocol. Let us say you have a sender who has a set of frames and you have a receiver who is receiving the frame, sender and receiver. So, you have the different frames F0 to Fn like we have seen in the window F0, F1, F2, F3, F4, F5, F6, F7. Let us say we are talking about one window only. We are not considering the sliding or expanding or the shrinking case, that happens automatically in the sliding window flow control. What we see within a single window, when the transmission of frames takes place, how the error is being handled, that is what we are seeing, right. So, now let us say F0, F1 and F2 are transmitted. So, arrival of F0 is a success, arrival of F1 is a success and arrival of F2 is error. That means there is an error here, right. And by the time F0, F1 and F2 they are arrived, the sender has the provision, it can send more frames, right. So, let us say after receiving F0, this fellow sends the ACK1 acknowledgement for the first frame. It can send, it may or it may not send, let us say it sends. That means at this point the sender receives that the receiver has received the frame 0 correctly and now it is expecting frame 1 and already frame 1 has been transmitted. So, it does not bother for that. Anyway, so before F5 what happens? After sending F2, F3 has got the provision that it can send F3 as well and F4 as well because of the mechanism of sliding window. Without waiting for the acknowledgement, it can send. So, now let us say F4 is correct and F5 is also correct, right. So, now this fellow is busy in transmitting the frames from the sender to the receiver side. But what happens at the receiver side? After sending acknowledgement 1, it finds that there is an error in the frame 2. So, what it does? It sends an NAC message, NAC for 2, NAC for frame 2 because frame 2 has got an error. And when it reaches at the timing of T7, the NAC message comes. So, in between it may happen that the sender has transmitted all the frames from X5, X6 everything and it may also send F7 also. It may also send F7. So, F6 and F7 all have been transmitted by the sender and in the meantime it receives a NAC from the receiver that NAC 2 was or frame 2 was erroneous. So, what the sender does at this point? Because there is a NAC and already the frame has been transmitted, it has to go back to all along the frame that has been received in an erroneous form F2 and whatever frames that has been received by the receiver, all the F3, F4 all those things till F7 they are being discarded. they are being discarded by the receiver because there was an erroneous frame and that frame is required to be retransmitted. The reason is that the receiver cannot receive a frame or cannot process a frame which has come out of sequence. So, without F2, if F3 and F4 comes to the receiver also, it cannot do them, process them unless it receives the F2, right. So, what it has to do? It has to drop all the frames since the erroneous frame and it has to wait for the frame to be transmitted again. So, now comes your F2 again. So, F2 will be transmitted somewhere here. So, F2 comes now and then again the same set of frames those were transmitted after F2 will be transmitted, F3, F4, all those. Now, let us say all these frames have been received by the receiver and this is for F3, this is for F4 and this is for F5. And the receiver now sends an acknowledgement at F4, acknowledgement for 5. It sends an acknowledgement for 5, right. What is the meaning of this? What the receiver or what the sender will interpret to get the act 5? It has not sent any of the acknowledgement in between, no acknowledgement was there in between, but what it does, it sends an acknowledgement for F5. What it indicates or how the sender interprets this? Whether the successful transmission or there was an error in the transmission in between. So, all the transmission from F2 till F4 were successful. That is the reason why I did not receive any NAC in between, and if I am getting an ACK for next one, meaning all the previous frame has been received successfully and they were being processed. So, any NAC in any ACK indicates all the previous successful transmission, a single NAC says there is a error in the current frame. So, the receiver does not have to send multiple ACKs at a time, I mean several times ACKs. If it sends only one ACK also, that that indicates that all the frames has been received successfully. Along with that, the frame control, the sliding window, all those things mechanism will be taken care of, as in case of your flow control. That means your flow control and the error control can be combinedly taken care of by the DLL while considering the sliding window protocol for the error control mechanism, right. Yeah, if that is true, if the acknowledgement contains if the acknowledgement also contains an error, the sender too has got the error detecting mechanism, right. This will be again considered as the retransmission case, because it does not know whether this message is a NAC or an ACK. So, again the same retransmission will take place and the duplicate discarding will be taken care of, right. So, this is our go back n. So, the name in itself indicates it has to go back to the n number of frames, and for the retransmission, so the name is go back n sliding window error control protocols. Now, tell me what could be a solution for this protocol? What could be a better solution for this protocol? If the receiver would have been a smart receiver or it would have been equipped with some more intelligent things, then it could have saved or it could have buffered all the frames that it receives after that without dropping. The reason is because they have been arrived successfully, it has already consumed your resources. So, if you are dropping them or discarding them, it is not wise even. You are misutilizing the channel resources or the network resources. So, there could be one solution, let the receiver has a provision of buffering all the frames that are coming successfully to it. So, keeping that solution in mind, the next version of the error control protocol that has come is the selective repeat protocol. You can say selective repeat, you can say selective reject also. So, anything is, any name is okay for this. Selective repeat error control protocol. Now, what happens in this protocol? You have the same scenario, you have a sender, you have the receiver, and the condition or the assumption for this kind of protocol is that every frame should be acknowledged. Every frame needs to be acknowledged. Why? We will see that, right. So, now we have again F0, F1, F2 up to same thing up to F7, let us say. Let us consider the same scenario. Your F0, F1 and F2 have been transmitted. F0 received successfully, acknowledged with the current number, not the next number, because individual frame is now being acknowledged. So, it says acknowledgement 0 means I have received the frame 0, right. Then F1 received successfully, this also sends an acknowledgement ACK1. This is F2 error, it sends the NAC for this, NAC 2, and at this point when the sender was supposed to send F6, your NAC comes here. So, in between it could send 3, 4 and 5, it can send. So, now let us say the F3 has been transmitted, F4 has been transmitted and F5 has been also transmitted. All three have been now transmitted. So, in the meantime when it was supposed to send F6, it checks that a NAC has come now. So, instead of sending F6, what it does? It has to send F2 now, right. That means what? The sequence was after F5 it was supposed to transmit F6, but it is not doing this. What it is doing? It is transmitting after F5, it is transmitting F2. That means the transmission in the sender side is out of sequence, right, out of sequence, because after F2 again it has to send F6. That means the transmission is F5, then F2, then again F6. So, the sender must be smart enough, or it must be equipped with a complex algorithm, so that the sender should be able to transmit out of sequence frames. That is what happens at the sender side, correct. Now, what happens in the receiver side now? After this NAC has been transmitted, the receiver receives F5, F3, F4 and F5, and all these frames are success. The transmission is a successful transmission. So, they should be buffered. They should be buffered by the receiver. That means the receiver should have the provision buffer the frames arrived after the error frame, right. So, now what happens? At F6 time when F2 comes here, the receiver must be able to process or reorder the frames F2, F3, F4 and F5. So, the receiver should be can reorder the frames arrived. With this condition only we can think for a selective repeat. So, how many files or how many frames are repeated? Only one frame, that is frame number 2. So, rest all the transmission remains intact, your channel utilization is not wasted, your resources are not wasted. So, only if there is an error in the frame, the particular frame will be transmitted and the others take the transmission in a normal way. But to have this protocol work or implemented, you should have these many provisions. Every frame needs to be acknowledged, maybe a positive, maybe a negative, and the sender side think that there should be an algorithm, complex algorithm it should be able to run, so that any frame which has an error that has to be transmitted out of sequence, and the receiver side also It should have the buffer space to hold all the frames that have been transmitted after the erroneous frame, and after receiving the correct frame, it should be able to reorder them or again keep them in sequence and send to the upper layer, that is the network layer, in sequence to assemble them. That is what is the job of your sender side DLL and the receiver side DLL. When this is possible, we say selective repeat can be a better solution. Now, what is the drawback of this solution and what is the strength of this one? The drawback of the previous one, I mean the go back and multiple retransmission, that is clearly visible, right? And the strength is less memory for what? No need buffering at the receiver side, right? But tell me which one is a costlier device, the channel or the buffer at the receiver? Obviously channel, because bandwidth is a cost factor. That is more important than your buffer. Your technology is so fast now, you can add up any buffer size. But there is always a limitation for the channel bandwidth. So, being a network designer, which one you will prefer? The selective repeat. For that, you can develop the algorithm so that you have this provision. And another drawback of, another plus point of the go back N is, you need very less number of acknowledgements. But here every packet of every frame needs to be acknowledged, but again acknowledgement is a very small signal. So, you can afford to acknowledge every frame at the cost of wasting the actual transmission of the data during the retransmission. So, you can have a trade off between these two, the go back N and the selective repeat, to choose which one is a better option to use for the error control mechanism in the data link layer service.